Welcome to the Explainer. Today, we are diving deep into one of the absolute core concepts of modern AI. We're going to map it out for you piece by piece. Okay, so let's just jump right in with a huge question. How does an AI actually understand anything? How does it know the difference between a cat and a dog? It feels like magic, right? But there's this incredible idea at the heart of it all. Well, this secret isn't just brute force memorization. It's not about storing a billion photos. Nope. It's all about finding this hidden structure, like a secret map of ideas. A map that lets it navigate this massive, chaotic ocean of data out there. So, to really get this, we first have to appreciate the sheer scale of the problem AI is trying to solve. It is literally drowning in a world of raw, messy, unstructured data. A true ocean of information. And the solution, the lifeboat in this chaotic ocean, is a concept called latent space. This is that hidden map we keep talking about. It's the thing that brings order to all that chaos. So what is a latent space? Well, the word latent just means hidden. So think of it like a hidden, compressed map of reality. It takes something super messy and high-dimensional, like, say, the millions of pixels in a photo, and boils it all down to a much simpler, more meaningful representation. This really hits the nail on the head. Look at this. On one side, you've got the observable data. That's the noisy, chaotic surface of the ocean. But on the other side, you have the latent space. The AI learns to look past all that surface noise to understand the deep, organized structure underneath. That's where the real meaning, the real concepts actually live. I love this quote because it's so relatable. It's exactly how our own minds work, right? You don't remember every single photon from a sunset you saw. Of course not. You remember the feeling, the essence, the compressed idea of sunset. That's pretty much what a latent space is for an AI. But wait, why do we even think this map exists in the first place? Well, it's based on this really powerful idea called the Manifold hypothesis. It's basically the belief that meaningful data, like all the photos of faces in the world, isn't just random static. It actually has a hidden structure, a kind of shape to it, that an AI can learn to find and, well, map out. Okay, so if the data is an ocean and the latent space is the hidden map, how do we build the submarine to go exploring? How is this map actually made? The tool for this job? A deep neural network. This is our high-tech submarine. It's the only thing we've built that's powerful enough to dive into all that raw data, navigate the complex currents, and actually chart that hidden world of meaning. And it does this step by step, layer by layer. So the first layer of the network might learn something really basic, like just seeing edges and lines. Then the next layer combines those edges and lines into simple shapes, maybe an eye or a wheel. And then the deeper layers start putting those shapes together into truly abstract concepts like a face or a car. It's building up understanding from scratch. So how does the AI even learn to do this? This is the wild part. A lot of the time, it's through something called unsupervised learning. That means it learns without any human help. No one is sitting there labeling millions of images. Instead, the AI just practices. It tries to compress data down and then recreate it perfectly from that compressed version. And that simple act is a total game changer because it unlocks what you might call the dark matter of data, that 99% of the world's information that isn't nicely labeled for us. All right, so we've got our map, the latent space. We've got our submarine, the neural network. Now for the fun part. What amazing things can we actually do in this ocean of ideas? Well, first off, every single concept, every word, every image, every sound gets a specific location on this map. These locations are called embeddings, and you can seriously just think of them as the exact GPS coordinates for an idea. Meaning itself literally becomes a place you can navigate to. And because meaning is now geometry, we can do math with it. This is where it gets absolutely wild. The classic example is this. You take the coordinates for the idea of king, you subtract the direction or vector for man, and then you add the vector for woman. And where do you end up? Exactly on the coordinates for queen. It's actual math, with concepts. It's incredible. This whole geometric thing also means we can travel smoothly between ideas. We can literally draw a straight line between 2 points in this idea space. That's called interpolation, and just see what we find along the path. Let's try it. Imagine we find the exact GPS coordinates on our map for the concept of a smiling face. Okay, we're there. Now, the AI has learned that certain directions on this map correspond to specific attributes. So from our smiling face point, let's start moving smoothly in the direction that the AI has learned means age or getting older. And when we stop, we arrive at a completely new point, a new set of coordinates that represents, you guessed it, an old, smiling face. We've literally traveled from one concept to another, smoothly and logically. And this one single capability, this ability to navigate a map of ideas, is the engine behind so much of the AI we use every single day. It's how generative art models create brand new images. It's how smart search understands what you mean, not just what you type. It's how recommendation engines find other things with a similar vibe. It's all about navigating this space. Okay, so this leads us to a really profound consequence. When an AI gets really, really good at making these maps, what is it actually building deep down? This is the really mind-bending part. To get really good at compressing data, an AI has to start learning the underlying rules of our world. Think about it. To make a perfect map of language, it has to learn grammar. To map our physical world, it has to learn logic, maybe even some basic physics. So in the process of building a perfect map, it accidentally builds a working model of reality itself. And that leaves us with one last big question. If an AI builds a perfect, detailed, navigable map of our entire world, of all our knowledge, is that the same thing as actually understanding it? Definitely something to chew on.